podcast and YouTube blog covering the German startup scene with news, interviews, and live events.
Hello and welcome everybody. Grüezi, I can say, to Startuprad.io, your startup podcast and YouTube blog from Germany, as well as the world's first 24/7 internet radio station dedicated to tech companies and startups. Today I was welcoming you guys with Grüezi, and the reason is this is hello in Swiss German, and I do have a startup from Switzerland here with me. Hey Pablo, how you doing?
Hey, hi Joe, how are you? Guten Morgen.
I'm doing great, thank you. Guten Morgen, exactly. You are not per se the typical Pablo Garcia-Amorena. It's not a typical Swiss name, but we'll get to this very soon. But let us first talk a little bit what you've been doing, what you've been up to in your life. Before that, guys, if you like this interview, make sure to go down here and hit the like and subscribe button as well. There will be a link to the show notes, and there you can find many more information, an automated transcript, and the links to the company website as well as to Pablo's LinkedIn profile. Now that we have this out of the way, Pablo, what have you been doing in your life? Because it looks like from your CV on LinkedIn, it really looks like you're originally from Catalonia, the area in Spain close to Barcelona. Is that true?
I'm from Barcelona. So I studied there. I studied mathematics and engineering. So my life basically is about studying and working in the field of mathematics. I really like solving problems and getting into hard engineering problems, with always having a balance between the theory and the practice. So in Barcelona there was a center that was dedicated for that, for students who could study 2 degrees at the same time. So we would study mathematics in the morning, and then we go to the faculty of engineering in the afternoon. It was very good. And in this center, it was inside the Polytechnic University of Barcelona. There was these programs to study abroad. It was part of Erasmus, and then I went to Switzerland to the Swiss Federal Institute of Technology. It is in Lausanne. So in Switzerland there are 2 institutes of technology, one in Lausanne, one in Zurich. So I went to the one in Lausanne because there was this flagship program in. I don't know if you know about this EU flagship program of research for brain research. So it was this Swiss Technology Institute was given a very big grant to do research about biomedical engineering in general, but more specific in modeling the brain and the neurons. And this is still ongoing. So I was very interested into how to solve problems in the biomedical field, from the perspective of mathematics. So I went there, and then I studied this master's in computational science and engineering. It is called. Is again computational engineering problems with perspective of mathematicians, to have this bridging between the 2 fields. And then I ended up in this laboratory where we were doing processing of biomedical tissue, of CT scans, computer tomography scans, magnetic resonance imaging, electron microscopy. So basically about processing images of the brain, images of the heart, of the body of a person, but also images of very small cells in a laboratory. So then we were focusing on these problems of image processing. And then in this laboratory, I met my 2 co-founders of this small startup that is called Mirrakoi. And then we got into this project. We just wondered, hey, how could we do a real application, a real world application? How we could make a product out of this research. And then we started this project of doing a startup. And that's where I'm here.
I see. That is very interesting. What I found intriguing is when you talked about studying mathematics and engineering at the same time, you were really smiling. You were enjoying this time, right?
Yeah, yeah, absolutely. Yeah. It's
For,
really, really amazing. Yeah.
for
I
most
mean,
people, it is tough to study only engineering or mathematics, but you enjoy doing both. Okay, okay. I get this. There are some people out there who like that.
no, yeah, I mean, it's really, people should lose the fear to study mathematics specifically. I mean, it's really, really enjoyable.
Yeah, and we should add because approximately somewhere between 50% and 2/3 of the people listening to us are living outside the European Union, which by now also includes the UK. And we should add here that the Erasmus program is like a European Union funded exchange program where you can study abroad for some time within the European countries, and sometimes exchange to other countries, where everybody should know that Switzerland is neutral and not a part of the European Union, even though they are surrounded by on all sides by the
I
European
should add
Union.
that when I went to Switzerland, it
And
was in 2014, and Switzerland was still in the Erasmus program, and then there was this vote to get out of the mobility or Schengen area. Then it got kicked out of the Erasmus, but then I think they made their own program to be compatible with Erasmus. So there's still the opportunity for people who want to do something similar.
so there. Okay, so there's a own Swiss program. Okay, I see. And we should add that all the medical machines you talked about, like X-rays, like a magnetic resonance tomography or whatever is out there, it's like image giving instruments. So you lay in, you get some X-rays, you get some MRT, and basically that helps your physician, your doctor, to actually determine what is going on in your body without the need to actually cut it open and look at it. And in some cases, as you said, for example, in the brain, it's not very easy to cut the skull open, and you'll only do it if it's really, really, really required. And that is the area we are talking about. So you guys are actually a med tech startup, right?
Yeah, exactly. So we really work with hospitals, with surgeons, with clinicians, and we see we normally we get material from this hospital, confidential material of images of patients, and we have to segment, specific tissue of it. We are segmenting now. We are focusing on bone because it's easier than soft tissue of cardiovascular, and we focus right now. We are focusing, for example, on reconstructing fractures or reconstructing parts of the bone that are very, very hard to cement. Here, for example, I have an example of here we have this problem. I don't know if you see well. So we had this patient that has a fracture.
So for all the people in the audio podcast, he's holding up a part of the 3D printed skull, maybe starting above the mouth and going till like the middle of your forehead.
Yes. So the problem was that the patient had a fracture in the orbital floor, and
so it's below the eye for everybody who's not in medical field.
Yeah, sorry if I go to.
Yeah, don't worry, I'll explain it. Yeah. Totally fine.
So in a traffic accident, the patient has a big trauma, and below the eye has a fracture of the bone, so it's broken. And normally, this is very hard to cement. It's hard to find that particular hole, because if you open your CT scan, you will see a mix of tissues, a mix of things, a mix of blood or the cartilage, this close to the nose. And so what the clinician wants, is to have a model of the patient and see, okay, I see the hole inside the patient is exactly there. Because then, before the operation, because the clinician has to put a metallic plate out there to fix that hole. So the clinician would like to see this hole beforehand, before the operation, because when the clinician is in the operation, then there's no time to hang there and see, hey, how is the hole? We should choose this plate or choose that one. There's no time to lose in the operation room. So it's better if the doctor already knows what's happening. So this is part of the idea of the whole project. It's about giving some more information to the doctor, be it 3D, be it a 3D print, or be it whatever that is useful to give information.
Yes. First and foremost, very sad accident, very poor patient there. And basically, before you guys were around, the doctor had no other choice than opening up the skin and actually physically had a look. And as everybody, sorry if you're just eating, can imagine, there's like blood and other bodily fluids flowing in the way, and you can never really good see during the surgery what is going on there. One of the many problems surgeons are facing. So basically that is the point when you come in, because you basically got the imagery of the patient, you separated the different like layers, the different types of structures, the soft tissue, as everybody like call the skin, or the tissue underneath it and stuff like this, from the bone, and then you can actually 3D print a model of the damaged area of the skull, and the surgeon can really take it, have a look at it, memorize it, and even can make with some I would assume he has some non-sterile parts that he can play around with, and can actually test in the 3D model which one would fit best, and then he orders a new sterile one and actually has this at hand at the surgery, which gives like a huge leap forward for the surgeon, because he has not to make everything up on the fly while he's actually in the surgery. So just imagine, guys, you're in the surgery and then you find out, oh, we don't have the right, let's say, parts here. So what we're going to do now, we have to make something up. And that's the stuff you are really avoiding there, right?
Yeah, exactly. And it's important to note that we focus on models for preoperative planning. That means that is to give information to the doctor. So these models will not end up in the patient right now. Okay, so that's a very different kind of thing. That's about implants, about we have a pilot project of what we call surgical guides, that are models that let the doctor put elements into the patient, like screws. So we have a research project for that, but it's not part of the product itself. So right now it gives a region, anatomical regions that we call. So like skulls, like part of the spine. Here I have another example of a spine. So I show part of the column of a patient that is 3 vertebrae. And in this case, the doctor...
For everybody who's not in the medical field, vertebra are the little pieces of bone your spine is made up of.
Yes, so in this case, the patient had this say it's called scoliosis. It's a bit of a deviation of the column that is congenital. Okay, so it's this.
Everybody who's watching now at my picture can see this. My left shoulder is a little bit lower than my right shoulder. That's also a scoliosis. That's what you're talking about, right?
It's about these people who are really, really bent forward.
They have a hunchback,
Exactly.
like stuff like this.
Exactly,
Really bad. For me, it's like a little bit lower left shoulder, but for some people, it's really bad, and that's the cases you're talking about, right?
So this is treated with an operation that is called lumbar fusion. So the doctor will put screws in several of the vertebrae and put a plate that is straight, and will put the column straight. Okay, so he will do it in 2 or 3 levels. So the doctor has to put screws. He has a driller and has to put screws inside the operation. So first, the doctor, if he has a model of the column, it's already much better, because the doctor already knows, okay, so I will find this when I open the patient, in the operation room. And then second hand, and this is what we are doing for research purpose, is to have what we call surgical guides, that are these tubes that I made, that you see here. These are 2 tubes that you print alongside the column, and you put them on top of the column, and they fit properly. So you see here, my column has 2 tubes that are fitting the vertebra. So the doctor, during the operation, well, this will be sterilized, of course. This will pass a proper requirements of safety. So the doctor will put the driller with a screw in every tube. So the doctor will already know where to put the screw. Otherwise, the doctor, if doesn't have this, he just has to try. Okay, it should be here. So I follow my intuition.
Yeah, I imagine the doctor really has to first open up the patient and then has a look and then really, really, really think hard where and when and how deep they actually should put it, because you don't want to damage the nerve tissue inside the spine.
Exactly,
right?
because you have the spinal, the medulla, that goes through your column, and it's a very important part of your neurological system. So it's a concern. I mean, these operations are made by very experts. You cannot just do it, without prior intuition or experience. So this is very good. This, but as I told you, now we focus on the anatomical region of interest, and this is the future. This is where we come after that.
Yes, I can totally see that. At the beginning, I was wondering, but let me first, before I ask my questions, let me first clarify a little bit. You guys, as the people who see it right now on YouTube, will have seen you guys are actually doing like the imagery. The 3D printing everybody could do, like except for the like 2 channels for the spine surgery, everything 3D printed like every 3D printer could do. That's not your USP. That's not what you're working about. You guys are actually good in like getting the real data out of the medical imagery, the medical data provided by the hospital, by the physician, by the surgeon, whatever, to actually get a real good 3D model. That's your first point. And the second point is then you can actually help with like additional instruments like 3D printed material, like the columns we've seen, the channels for the drill and stuff like this. You can then actively help the surgeon. That's what we are talking about here, right?
Yes. So what we do is exactly the software. We do the software that takes as input CT scan or tomography or medical imaging, and gives us output a 3D model in digital format. So an STL file, stereolithography is called, or any kind of CAD model that can be output towards the 3D printer. So we are compatible with any 3D printer in the market. But it's important what you said, that we focus on how to convert this imagery into a 3D model digitally. So that means that we are not married to a particular 3D printer technique or facility. And what's more, even we have met some people who don't even want 3D printers, that they want virtual reality, for example, or that they just want a visualizer. So they want to see in the computer, they want to see the 3D model and rotate around it and make zoom, things like that.
That was actually the next point I was trying to make, until I saw like the 3D printed channels you can attach during surgery to the spine to get the right drill and the right depth. I was wondering why you not do it like completely virtually. I do believe you're working on this. Plus, I could imagine like a doctor having like some type of a very advanced version of Google Glasses during the surgery, and actually you could guide him. Is that the way you're going?
Yeah, absolutely. Yeah, and this is going, it's going mainstream. I mean, I see there's some experiments of surgeons having augmented reality and virtual reality on scene, where they have the operation and they have I've not seen in person. I've read about it. So they have the model, the 3D model that is somehow an hologram, no? Something that is put on top of the patient. And this is very, very useful, for example, when you are operating arteria or veins, that you have to treat a particular arteria, and it's hard because in the operating room everything is red and dark. No, so if you superpose an anatomical model with augmented reality, you can see, for example, one vein in one color and another vein in another color, or part of the bone in one color and the other like this. So the doctor can much better see what's the tissue that has to cut, or the element that has to modify. So this is where it's going in the future. So to mix everything, virtual reality, augmented reality, maybe a 3D print, in order to have much faster surgeries and much better outcomes. It's less risk to the patient in the end.
And I can now totally see the use for a 3D printer, or even more 3D printers, more than one, in hospitals, because if they can actually prepare a helpful equipment like you've been showing it here in the video, that's totally a very good case for 3D printing in medicine. And maybe at one point in the future they will actually be able to print tissue and bone there as well. That would be just amazing. One more question. I've also found you guys on Crunchbase. They say you had one funding round. No, with 3 investors. Yes. And actually, how you guys are financed right now? Are you looking for external investors?
Yes. So right now we didn't have investment. So we were raising money in the startup scene in Switzerland and in Lausanne through grants for bridging research towards private sector. And right now we because of the pandemic, we had to make some restructuring of activities, focus on the core software and core partnerships. So now we are bootstrapping still through this process. We are not looking for external investment right now, because we are looking for outcomes of these research projects and collaborations. But I think that in 1 year, more or less, we will have very concrete roadmaps for the future, and then we will look for investment. So in short terms, we are right now bootstrapping, and we will go for investment in short.
And our interview today is due to the arrangement of HV Labs. You can learn a little bit more in the interview part with HV Labs that we just attached to this interview. But can you tell us a little bit about HV Labs and your experience there? By the way, HV means Health Venture.
Yeah, Health Venture Labs is an accelerator program that is funded and organized by General Electric Healthcare in Hungary, because they have the very big quarter in Hungary. And we participate in that accelerator last fall, and it was really, really good, because we met several companies in the health sector that we are all based in Europe, and it was very good to network and to find people who face similar problems to the ones we face. Problems biggest problems were these related to regulation, certification of software as a medical device, and we had a lot of advice in that field. And very and related to imaging, for example, I met several people who had also dealt with CT scans and how they are handled. They all follow a standard that is called DICOM, and it's very, very complex standard. No, so you have to really get into that world in order to understand So we, thanks to HV Lab, we managed to get development going in that direction. So I really thank Kat who introduced me to you, actually.
We may add that Kat is Ekaterina, and she is the person in charge of PR in this program. And actually, she will not appear in any of the videos, but thank you very much.
Yeah. And also something interesting that you mentioned, the thing about the material. So right now, the 3D prints that I show are in resin that are like some kind of plastic, no? But the 3D printing technology is really advancing at a crazy pace. So now you can print with any kind of material, with metal, with food material, no. But now there's the bioprinting materials coming on. So printers will print. I don't know if exactly bone tissue or soft tissue, but something that really resembles that tissue, no? And something that at some point will be clear for regulation and will be allowed to be put as implant or as extension of tissue into the patient. So that's also where we are really going forward to. We are looking at that for the future. I mean, this is at some point.
Basic.
Yep.
And my understanding is that you can then use your software when you're at the stage where you can 3D print the replacement for, let's say, a little piece of bone or soft tissue, and your software actually would give the dimensions for this, as well as help the surgeon prepare the implantation of the artificial bone, right?
Yeah, exactly. I mean, we will not. It's like right now we are already ready to print whatever. For example, in an operation of mandible reconstruction, you have to use some bone from the fibula of the patient. So you can think of a situation where you will not need to make this reconstruction with bone of the patient. That you will be able to print part of the mandibula in bone tissue or something that is compatible with the patient. So we can think about that. But in terms of our activity, right now, it's like we don't depend on that right now. No? That's some work for the 3D printing industry to develop.
You're just there to tell them what to do, right?
Yeah, exactly. Yeah, I mean, we have to give all the responsibility to every actor involved.
Yeah, I like your smile doing that. Thank you very much. It was muchas gracias. It was a pleasure having you as a guest. And best of luck for your future endeavors, as well as for the patients and the surgeons there.
Well, thank you, Joe. It was really, really nice having a chat with you.
Thank you. The pleasure was all mine.
And please, and also just one last thing. So you can try our software for free in our website, Mirrakoi.com, and you can just contact, all the audience to just try the software and contact us to get to know more about it.
Links for the download will be down here in the show notes, of course. Thank you very much.
Thank you, Joe.
Bye-bye.
Bye-bye. See you.
Hey guys, we just talked to Mirrakoi and we talked about the HV Lab, also known as the Health Venture Lab. And now I have Daniel here who's running this Venture Lab. Hey Daniel, how you doing?
Hi, great to be here. Thank you very much for having me in your podcast and your show.
Yeah, and we waited here for 20 minutes because we got all kinds of technical problems. But now you're here. Very glad about this. Tell us just a little bit about HV or Health Venture Lab and what are you looking for in your next application round, plus when people actually can apply.
So Health Venture Lab really came together under the wings of GE Healthcare and the European Union body called EIT Health, which is European Innovation and Technology. And basically we help healthcare companies who have already developed the minimum viable product and are currently building out their early customer base. And we are basically connecting these startups with experts in the field of healthcare and helping them, build this customer base. So we have a program running where the recruitment is actually ongoing right now, which is finishing in the middle of March. And we look for startups all over Europe. Actually, one of the biggest advantages that you have a European-wide base of startups that actually can help you. So they are in the similar shoes and you are, also trying to tackle a hard problem like healthcare. And so you can. I would advise to go on our website to check it out. But that's basically it. Mid-March.
Of course, everybody who'd like to learn more, you can go down here in the show notes. There we'll link Daniel's personal profile as well as the HV Lab. Tell us a little bit about what the people can expect now with Corona. Will it be an all remote or in-person accelerator program? Where are you guys headquartered, and what else do you do? Then send them to meetings with the CEOs where they drink coffee.
Yeah, that's a great question. So the first question was, how does it look like in Corona? So Health Venture Lab was based on physical programs, but because of Corona, we, as a lot of other organizations, we had to reinvent how we do our programs. And fortunately, and so it's kind of an interesting push, we experienced that our digital programs were far better in some sense than our physical ones because it actually saved a lot of the time for startups, which they spent on traveling. So we could actually provide value in the right time and in a very efficient manner. So this program is also going to be run entirely remotely. The Health Venture Lab team is connected to the GE Healthcare here in Budapest, in Hungary. But just like GE Healthcare is a multinational organization, we have connections all over Europe and actually also to Boston, and we are also collaborating with universities like the Medical University of Łódź in Poland, ISC Business School in Barcelona, but also local universities here in Hungary, called University of Debrecen, for example. And so it's kind of a network of partnerships. So although we are based in Budapest, it's really a Europe-wide wide organization and program. We actually have a lot of, I know that you are based in Germany, and that a lot of your audience is in Germany, and so we had a number of German startups during our program and in our alumni. So we also welcome healthcare startups from Central European region and Germany specifically. We have very good experience with the startups from there.
Mm-hmm. Admittedly, we are also popular in Croatia, in Italy, in the United States, in Canada, and many, many other countries. But basically, our focus is Europe and North America, and the rest of the world, they always make up 1/3. So where would you draw the boundaries for startups that can apply? Do you have any type of limitation?
We are really focusing on the European market. So we are trying to, although we have, as I said, we have contacts to North America, for example. This is more of a direction where we help European startups take a foot in the Boston ecosystem, and also develop together. For example, we have a program that Health Venture Lab takes part in called Catalyst Europe, which really aims, it's a program developed at MIT, and we, together with a lot of partners in Europe, we further developed to adopt it to the European market. And basically that's for researchers to go through the entrepreneur path and understand how to research into something impactful rather than into simply publications. So that's, for example, that's just an example of how actually we leverage our North American partners. but the startups themselves, they all come from Europe. So that's the only limitation. The other limitations are more qualitative. So where they are in the stage. So we are looking for companies who already have a product. It doesn't have to be super fancy, but something that they can already sell. They have to be incorporated, and they have to be dedicated on actually learning business methodology about the healthcare market and networking. So these are kind of the criteria that we look for when startups apply.
I would have one more question before we wrap this up. Is there like a really specific type you're looking for? You always talk about research. Is it more like research heavy, like biotech companies you're looking out there, or everything related to healthcare? Because you could also have an app where you can store your X-ray pictures, which would also qualify as healthcare. Is there a certain type of startups, a certain orientation you're looking for?
We have a soft focus with our program called Reactor, which we've talked before. We look for medical imaging companies, but it's a soft focus. So around 60% of the startups who apply to us or who we are going to fill up the course is going to be related to medical imaging. But we are more driven by finding great teams and great technologies. So we had a lot of hardware companies, for example, that's related. It can relate to medical imaging, but it can relate to a lot of different fields. What I personally prefer, but it's not really a criteria, is to have deep tech companies. So actually companies that are not just a marketing product, they are more based on technological or research innovation. However, as I said, so this is a preference, but we have startups where we thought that the team is so interesting, so ambitious. There was not necessarily a great leap in technological innovation, but in terms of product innovation, so we also accepted those. So we have a soft focus and a preference for medical imaging companies, which are hopefully deep tech. But I encourage everybody who has an interesting healthcare product. We don't work with pharmaceuticals, but for really life sciences healthcare companies. If you feel like if this fits you and you can leverage industry giant like GE Healthcare, the expertise and the universities around that. I'm sure the audience who hears this will understand if they fit this criteria or not.
Just to be clear, you would also take in an app which allows to arrange dates for people to go to cat owners and pet their cats for medical purposes. That's also fine. That's also something you would consider?
We would consider, although I would say they have a tough competition. So I can give you an example. We had an app called Doki app, which was really about booking medical professionals. But this is not necessarily the generalized. The generalized would be, for example, we had another company called Baby Index. They are looking for crystallizing. So they look for crystallization in the saliva of women so that they can predict the ovulation period. So this is also an app with actually a microscope attached to your phone. But actually the research behind it and how they do it requires a bit more depth of research and development. But I wouldn't say it's necessarily, we are not, how would I say, arrogant about, this is only an app. It can be an app if it addresses the right problems and with the right tooling and with the right team.
Great. Thank you very much. And everybody who would like to learn more, go down here in the show notes. There are links to Daniel and the HV Lab. Thank you very much.
That's all, folks. Find more news, streams, events, and interviews at www.startuprad.io. Remember, sharing is caring.